Good evening. I'm Terry Gross. We have some of the best seats on Earth to witness a cataclysmic event now underway in the solar system. You know, today we're commemorating the 25th anniversary of the first moonwalk. But the fact is, this week, we humans are being upstaged by a comet train which is crashing into Jupiter. Actually, this marks another achievement for science. It's the first time we've ever been able to watch what happens when a comet collides with a planet. The impacts are more spectacular than expected, as you'll see. We're hooked up with NASA, the Hubble Space Telescope, and amateur astronomers around the world. We're even wired up to the internet, so professional observers and backyard sky watchers can all report their observations on our email address, which will appear on your screen. With me is astronomer Derek Pitts. He has the latest images of the impact. Hi, Derek.
Good evening, Terry. First of all, we're going to start with a look at the images of the most recent fragment impacts, which happened just this afternoon. With us are the first people to see the string of pearls. Comet discoverers Carolyn and Eugene Shoemaker, and David Levy via satellite from Washington. Here with us in Philadelphia is Dr. Heidi Hamel of the Hubble Space Telescope, imaging team who was among the first to see space telescope images of the bruised planet. Heidi, welcome. Nice to have you here. Let's take a look at these first images here that we have. The first images that we're looking at came in this afternoon, and these are the images of fragment K. And as we take a look at our monitor here, we see we have 6 images up right now. And why don't you tell us a little bit about these images if you can?
Well, this is the first time I've seen these images, but I'll tell you what I know about them, and that is we're looking in the infrared here. We're looking at heat from Jupiter. And what you see is that these features are hot. The bright spots that you see down near the bottom of these images are hot spots that are created when these fragments crash into Jupiter.
So when they hit the upper atmosphere of Jupiter, they expend a great amount of energy, and the infrared imager on the telescope for this particular image actually detected that as heat, and we see that as these bright spots.
That's exactly right.
Now, can we also see some rotation in the planet Jupiter as some of these spots might move across the surface?
I think that's exactly what we see here. And
Okay.
we've been seeing that with telescopes all around the country.
Okay, and over here in this image, I think we might even be seeing, let's see if I can get, there we are, a telestrator working there. We can see 2 images, one on the leading edge and one on the trailing edge of
That's
rotation.
right. Well, at this point, there have been so many impacts happening that any particular view of Jupiter has at least 1 or 2 of these impact sites there to see.
Great. David in Washington, good evening. Glad you could be with us.
Hi, how are you?
Fine, fine. As you can see these images here, what's your impression of what we've been seeing so far in some of these images just from today?
I think this is the most fabulous thing I've ever seen in my life. Of all of the things that I could have hoped for the death of our comet, I would never have expected something like this. Not only are these the most fabulous things I've ever seen in astronomy, these images, the planet has so many dark spots on it right now, spots as dark as satellite shadows, that apparently people with small telescopes, amateur astronomers with small telescopes, can even see these things. I am absolutely flabbergasted and delighted about this.
Well, we're going to be taking a look at some of those images a little bit later, David, so we'll get to see some of those dark spots. I'd like to ask Eugene what he thinks of what we've been seeing so far. Eugene, we've been watching these impacts, and we know that they've been doing some damage in the upper atmosphere, but how does this impress you with your background in cometary impact and cratering?
Well, we have attempted to do modeling of what to expect with very complex numerical codes on a computer, and when we saw the plume of nucleus A, the impact of nucleus A, it looked very much like a simulation that had been done by my colleague for a 1-kilometer diameter nucleus exploding about 30 kilometers below the cloud tops. The height of the plume, its rise time, and its time of collapse fit the model pretty well. So I was just thrilled.
It looks like you'd be pretty excited about that. We can understand that. Now, Carolyn, when you looked at this comet for the first time on the photos that you took that night with David and Eugene, did you ever expect that the results that we've been seeing so far would be anything as spectacular as this?
I wouldn't have dreamt that they were. I would like to have thought that they would be, but I didn't really expect to see that sort of thing.
Well, as we continue looking at these images, I'm sure you'll continue to be fascinated with what we see here. So we have a lot more images that we'll be looking at this evening. Before we move on to our next segment here, Heidi, I'd like to ask you just one other question here. As we're looking at these images, can you tell me anything about the progression of the brightness of the images as we go from the top row down to the last row? Our images are just... as we go here, you can see that we have one set of images at the top of the screen, another set of images at the bottom of the screen.
Well, the set of images I'm seeing on the monitor right now looks like the beginning of a feature starting to appear, one of these gigantic explosions blasting out from the side of Jupiter that by the end of the, in the middle of the third image, down the bottom, in the middle image, it's gotten very, very bright.
Right there.
That's right. And then it fades out again. These are very short-term things, only about 10 minutes from beginning to end, or maybe 20 minutes total, that these plumes rise up to thousands of kilometers above the limb of Jupiter before they sink back down again. And we'll see some Hubble images of that later on, probably.
We have some good ones. We'll come back and look at those again. Now, stick with us. We have a lot more images to look at tonight, and we'll see a lot more of these impact images in the cloud tops of Jupiter.
The comet crash has given us something else to worry about. Could it happen here? In Arthur C. Clarke's novel Hammer of God, it already did. Clarke is best known as the author of 2001: A Space Odyssey. He's joining us from his home in Sri Lanka by video phone, which is just the phone you'd expect him to have, considering how much he's written about the future of technology. Thanks for being with us, Mr. Clarke. Tell us what this week's comet crash means to you.
Well, of course, it is very exciting. I've been interested in this sort of thing for a long time. I expect you've seen my TV series, Arthur Clarke's Mysterious Universe, because one of the programs did discuss the Tunguska event in 1908, and we had some very interesting footage then made by the Russians when they examined the site some 20 years later. I imagine you're probably showing some of this on your program, because it does show what a relatively small bit of asteroidal debris can do.
Mr. Clarke, I'm wondering, are you seeing this comet crash in purely scientific, technical terms, or is it leading you to ask questions about the meaning and the design of the universe? I'm thinking like in 2001, for instance, you asked all these questions about intelligence behind the universe. Is this an occasion to wonder about that sort of thing?
Well, I don't know if it tells us much about any intelligence behind the universe, which I think is I think the universe is a machine constructed for the continual amazement of astronomers.
Okay. I should mention to our viewers that there's a little bit of delay on the satellite phone, and that's what accounts for the delay when we're talking. So you've written so much about Jupiter. Why is Jupiter of such special interest to you as a science and science fiction writer?
Oh, I don't say I'm more really interested in the Moon and Mars. In fact, I've just finished a book about colonizing Mars called The Snows of Olympus, and I try to show what Mars would be like when we started farming on it. But Jupiter, of course, is fascinating in its own right as the largest of the planets. And now, of course, it's really grabbing the headlines.
So do you have a telescope? Are you watching this?
I have a 14-inch telescope on my roof, and last night we fitted a TV camera onto it. Unfortunately, it's been very cloudy. We got some very nice glimpses of the moon, but we couldn't even see Jupiter, let alone the impact on Jupiter. There's one more chance tonight. In about 12 hours, another fragment will hit Jupiter when it's well-placed for observation here, so I'm keeping my fingers crossed, hoping I will be able to see something tonight.
Well, Arthur C. Clarke, we'll get back to you a little later to talk about the comet that wreaked havoc on Earth in your novel, Hammer of God.
So what happens when these meteorites, these cometary fragments, run into a planet? Well, something very small can make a pretty big hole. Now, let's say that this marble is a piece of comet or meteorite, and this box of flour is the surface of the planet Jupiter. It's not very hard. It's kind of gaseous. So here is the slingshot of science. We'll shoot The hard marble hurtling at the gaseous planetary surface at 50 kilometers a second. You ready? 3, 2, 1. You see how a small object moving fast can make a pretty big hole? That's what happened on Jupiter. But don't take our word for it. Try it yourself. You can get your own piece of the solar system and run it into your own planetary surface.
Thanks, Bill. The impact images are showing us large plumes that look very much, and also show us areas that look like ejection fields and debris fields. And we also see some features in these upper cloud decks as a result of these impacts that look like localized shock effects. Now, Cliff Stahl is an astronomer and a computer jockey from Berkeley, California. Welcome tonight, Cliff.
Delighted to be here.
Cliff, let's talk about what we're seeing when we look at some of these images. How is Jupiter's atmosphere holding up under this bombardment?
Yowza. First of all, the plumes show that not only do you get some cometary material coming out, but also the comet itself cuts through the ammonia layer, certainly, but we're not seeing any water evidence from spectroscopic observations, which means probably it's not going all that deep into the atmosphere. Otherwise, the spectroscopists would see water coming out of it.
Which is slightly different from what we did expect earlier.
I would have expected, yeah. I mean, look, there's the atmosphere is a clear gas, a thin layer of ammonia crystals, and then probably some clear gas, and then a thick cloud structure below.
Right.
And we're not seeing all the way down into that. Either the ejecta from the plume is obscuring that,
right,
or it's not getting that deep.
Let's take a look at the first image we have here and see if we can pull up any information about this particular, about what's happening with the atmosphere. In the first image, this is an artist's rendition of what we normally see of the atmosphere of Jupiter, just so people get a good idea of what we normally see looking through a telescope. We can see the cloud structure and the great red spot. Let's go to the next image, which will come up as one from, this comes from the South African Astronomical Observatory. And here we can see in infrared, this looks like a bright impact site. What kind of sort of damage or distortion might we expect coming from this cliff, from these impacts?
Well, what's neat about these images are the ones on display right now aren't taken in the infrared. They're bright. As Heidi pointed out, that means they're radiating heat away. Probably, essentially, all of it's from the heat of the impact.
Right.
In the ultraviolet, though, we're finding that it's the Hubble imagery is showing us that it's dark in the ultraviolet, meaning that, hey, we're getting obscuration of the backscattered ultraviolet light. Probably we're seeing dust very high in the atmosphere. Probably from the comet itself, doubtfully from the atmosphere of Jupiter.
So then we do have a lot of material coming back up out as a result of the impacts.
Which is highly neat. It's a chance to really get a flavor of the internal atmosphere of Jupiter, and also a sampling of the comet itself. So it's hot damn stuff.
And that's good, because that's just the kind of thing the scientists were hoping to look for. We thought we might be looking for too. Well, there's one thing for sure. The amount of energy being released certainly exceeds anything we've ever experienced.
These fragments of stuff from space smacked into Jupiter, right? And they had a lot of energy. People say they had 200,000 megatons of TNT worth of energy. Now, where did that energy come from? Well, when you throw a baseball, you're giving it energy. Now, what happens when you catch a baseball? Where does the energy go? Well, actually, it turns into heat. So when these particles hit Jupiter, they're turning into heat. Now, if this were Jupiter, this big, the particles that hit it were only this big. But they had enough energy to blow a hole the size of the Gulf of Mexico. It's a lot of energy.
Heidi, let's talk a little bit about the imaging process. You know, in our first image we have coming up here now, this is an image that has been taken with a C14, a Celestron 14, very much like the one Arthur Clarke talked about using, but this one has on it a CCD camera called an ST4. And the imaging process gives us an opportunity to see what Jupiter looks like just as a regular feature in the evening sky. But when we actually get to refining that process of looking at the images, we can collect a lot of information and get a lot of important information if we start to separate out the images. So let's talk a little bit about how that works.
Sure, that's a great topic. This is the kind of thing that an amateur with a good telescope might see. And it's a visible wavelength image. It's what you would see with your eyes looking through a telescope. But what professional astronomers like to do is put filters in front of the telescopes. And they may look at blue light, green light, ultraviolet light, infrared light. Looking at all these different colors of lights let us probe the atmosphere at very different levels. And if we could run through some of the other images in the sequence, we can show how Jupiter really changes its appearance with the different colors of light.
Okay. So actually what we can do is, as we're looking at the next images, we can start to go down further and further into the atmosphere.
Or higher and higher into
higher.
the atmosphere. That's exactly right.
Okay, that's good. Well, what we have going on here right now, coming up on the screen in this image, the images that we see here show us the different kinds of levels of energy that we can look at to see where we are. There are a number of infrared images.
Right.
There are a number of ultraviolet images. Now, as Cliff said, the infrared images show us heat in the atmosphere.
That's right. Here's an example of some infrared images. And what you see in this image, you see a lot of things. It's busy. There's a satellite there. That's what you see, that big bright splotch off to one side. You see the great red spot. The great red spot is warm. You see polar caps, and then this is a time sequence. You see nothing in the first image. The second image on the upper right, you see a little tiny thing appearing, and that's the plume appearing.
Right here?
That's right. And then in the next image in the lower left, a huge, bright, hot plume of gas being ejected out of the atmosphere, which then you can actually see it spread and fall down onto the atmosphere. And that's what makes the big splotches that we see in the visible. They're bright here because they're hot, but when we look with our eyes, they're very dark because they're dust or soot or smooshed up comet bits or who knows what. We're working on that to try to figure it out right now.
So it's the heat that we're actually seeing here that tells us a bit about the explosions themselves and the impacts.
And that's right. We look at different infrared wavelengths. We can actually try to get the actual temperature of these things by looking in near infrared and far infrared and all the way out to the radio.
Great, wonderful. Okay, well, there are more images to come. But, you know, actually, although there are no dinosaurs on Jupiter that we know of, actually, there is really a connection between this cometary impact and dinosaurs.
T-minus 10, go for main engine start. We are go for main engine start, T-minus 6, 5, 4, 3, 2, 1, and liftoff of the Space Shuttle Discovery with the Hubble Space Telescope, our window on the universe.
Mission Control, Houston.
Roll program. Roger, roll, Discovery.
The roll maneuver puts the vehicle in the proper launch plane, and both solid rocket boosters have separated.
Discovery, Houston. You have a go to open the doors. Roger, Houston.
Discovery, go free drift or plus SDM deploy. Capcom, we have a go for release. Discovery, go for Hubble release.
Congratulations on a super mission, and the world is looking forward to reaping the benefits of your good work over the next 15 years.
Comets hitting the Earth supplied all of the water that the Earth has. They supplied the basic elements of life, carbon, hydrogen, oxygen, and nitrogen. And 65 million years ago, a comet ended the lives of about 70% of the species on Earth. The first thing the comet does is it destroys the ozone layer as it's coming in. What takes nations decades to do, this comet did in a second. crashes into the Earth just off the coast of Yucatan, producing a crater approximately 150 miles wide. The temperature of the Earth's atmosphere in the half hour after impact reached that of an oven set to broiling. A total upset to the ecosystem, to the biosphere. And the Earth becomes virtually uninhabitable for years before finally things calm down. The stage is now set for new forms of life.
Back with us are the three astronomers who discovered the comet that's now crashing into Jupiter, Eugene and Carolyn Shoemaker and David Levy. Now, they didn't get this dressed up for us, by the way. They're attending a black tie affair for the Planetary Society. Eugene Shoemaker, let's start with you. Your comet is being compared to the one that crashed to Earth 65 million years ago. That's a long time ago. How often do events of this magnitude happen in the solar system?
Well, if we understand the magnitude properly, my estimate is that the original comet here was about 10 kilometers in diameter. That's about the size of Halley. And from our statistics on comet nuclei, I estimate that an object about that size hits the Earth on average about every 100 million years. Now, smaller comets will hit the Earth more frequently. So an object about a kilometer in diameter, 6/10 of a mile, hits the Earth about once every million years. Now, this is the size we're talking about for fragment A or fragment C.
David Levy, this is a real first. This is the first time we've been able to watch a comet crash into a planet. What's the significance of this event?
It has an enormous significance, and I need to have a drink of water. The reason I'm having this drink of water is that if comet impacts over the last many billions of years, especially when the Earth was young, if these comet impacts did not occur, the Earth would not have gotten its supply of water. So if you won't mind waiting a second, I'm going to have a drink of Comet right now.
So comets,
it tastes really good.
So comets actually have a function in the solar system.
Yes, but in addition to bringing the Earth's water supply, comets brought the beautiful, simple alphabet of life to Earth, the carbon, the hydrogen, the oxygen, the nitrogen. And 65 million years ago, as we've already seen, a single comet impact, at least a single comet impact, probably about the size of what's hitting Jupiter right now, the total effect of that, is what led to the destruction of 75% of all species of life on Earth, including the dinosaurs. So the significance of this event is almost beyond measure. The solar system, especially our Earth and especially our biosphere, was really built through comet impacts.
Carolyn Shoemaker, if you hadn't discovered this comet, would this all be happening up there in the solar system and we wouldn't know about it?
It's quite possible that we wouldn't know about it if we hadn't been lucky enough to find it when we did.
Yeah, listen, if you found out that this comet was actually heading towards Earth, would you still want it named after you?
I think I might want it named after someone else. But then it wouldn't matter too much.
Are you all going to be really sad to see this comet die? This comet is really, really old, right?
This comet is quite old, and we are sorry to see it die. We sort of had a moment of silence today when one of our favorite objects, impact Q, went in. And then we thought, well, it's going to make a big bang. We'll be happy with that.
David Levy, what are the pleasures of comet watching? You'll have to keep this real brief, but you've been doing this for years. You found lots of them. This is, of course, the biggest, but what do you love about it?
It's the most fun thing I've ever done, especially in the sky before dawn. I just stay out there moving the telescope one field of view at a time. It's just me, the sky, and the telescope acting as a phone link between the two of us. It's an awful lot of fun to do. I almost enjoy the searching more than the actual discovery. But don't get me wrong, it's great fun to discover a comet.
Especially this time around. Well, listen, we'll let you guys get some hors d'oeuvres. We'll be back to you a little bit later in the show.
Heidi, I'd like to go back and talk a little bit about some of the images from the previous segment and talk a little bit more about imaging, because that's really an important part of this. It's what teaches us the most about what's going on at Jupiter with these impacts. In a lot of the images, first we're starting out with an image here that shows us what the segments of the fragments look like. And can you tell us a bit about what's going on here with the imaging in Hubble?
Well, what you can see is a before and after shot, and not only do the images get sharper and clearer in the after shot, which is the one on the bottom left, but you notice that they change. This comet has been evolving as it's been moving around in its orbit on its way to its doom with Jupiter.
Yes, they've been moving apart. Some of the fragments have disappeared, I understand.
That's right, that's right. We haven't really seen any particularly new ones, but we're just busy watching them go in. This image shows two of the impact sites. This is A and C. And you can see the red spot there, too.
Great. So here's the red spot up here.
Yep.
And A is the leading one here, the trailing one right here.
It's the trailing one. And C is brighter. C came in a little bit later than A, if we get our alphabets straight.
There we are.
That's why it's brighter. It's a little hotter, a little fresher.
Now tell us a little bit about what we see right at the bottom of the image there. There's that large bright area that looks like it's the polar cap there.
Yeah, polar region. That's right.
So now, in doing this, the infrared is one way of looking at this, but what are some of the other wavelengths that we can observe in, and what kind of differences do we see?
Well, it really depends on what telescope you use. One thing that the Hubble telescope has been doing that can't be done anywhere else is to do observing in the ultraviolet. And we should be very happy that Hubble is doing that. The reason we can't do it on the Earth is because we've got the ozone layer, prevents us from getting sunburned by the ultraviolet rays. We may have some images from the ultraviolet light from the Hubble Space Telescope.
We do, and they're coming up. The next image we have up on the screen right now is a Keck impact, a Keck telescope view of an impact of fragment G at 2.2 microns, which is also in the infrared. And this demonstrates to us that there are telescopes around the world that are viewing in different wavelengths.
All over the world. We've got networks of telescopes just every single longitude on the Earth, and we've been getting electronic reports from Australia, from Hawaii, from Spain, from Chile, everywhere people are observing.
Let's go on to the next image and see if we can... the next image we have here is an image that shows us what some of the cratering looks like on the surface of the moon of Callisto as a result of this kind of collision of a comet with another moon.
That's right. And we had no good explanation for this until the Shoemakers and David Levy discovered that string of pearls comet, and suddenly it made a little more sense when we saw that crater chain.
So now with the ultraviolet images, again, what can we see when we're actually looking at those?
In the ultraviolet, we're seeing much, much higher in the atmosphere than in the visible. And so what we're seeing with these comet impacts is we're seeing the evidence for the dust that's been blown out by those tremendous plumes that we've seen.
Okay. All right. Now, are there any other wavelengths that we're looking in besides infrared, ultraviolet?
And visible, all sorts of visible wavelengths.
Not the most important
That's right.
one,
And we're also looking at millimeter wavelengths, and we're looking for chemistry at those wavelengths. And I bet, and also people are looking with radio wavelengths. They've been looking for, you know, tuning their radio frequency dials to Jupiter and listening for the signals. And they've been reporting signatures from these impacts. And some of them are still speculative, but it's very intriguing. It might be very real.
And so it's probably a little early for us to tell very much about exactly what's going on, but we at least have these ways of indication.
Yeah, it's too busy to know what's going on. Everybody is just frantic getting the observations done, and we really haven't a lot of time to think about what it all means. That'll have to come later after all these pieces are gone.
Now, in your work, you're certainly recording all this data for examination later. Okay, thanks a lot, Heidi.
Joining us on the phone is one of the zillions of amateur astronomers watching Jupiter tonight. Steve Lucas organized a Jupiter Comet Watch on the internet. He makes his living as an interstate truck driver, and he says that gives him plenty of time to think and wonder. Steve, how do truck driving and astronomy come together for you?
Primarily I transverse the Midwest region, and I'm in some very dark skies. And from time to time, it gives me an opportunity to get out and enjoy the night sky, the evening sky.
So what are you seeing tonight?
Well, tonight Mother Nature has been very unkind to us. We had a thunderstorm roll through here earlier, and yesterday was cloudy. However, I'm looking at a computer simulation from a friend from Texas, Dan Bruton, who right now I can see exactly what's happening on the planet of Jupiter, all the impact sites that are current as of right now. And it just appears that one of the larger fragments, the one that you were talking about at the beginning of the program, fragment K, is just coming over the limb of the morning terminator, so that observers tonight and in the western regions will be able to get a good shot at this object K coming around the planet for the second or third time.
Now, Steve, are there some, so these are some images that you've taken from your backyard. They show a very nicely resolved planet. Can you tell us some about how this was done?
Well, primarily, my colleague and I, Darren Drake, have been using video cameras, and of course there's been fellows down in Florida and who have been imaging with CCD imagery, Mr. Beach and Mr. Parker and Mr. Palometti. Down in, believe this or not, Jupiter, Florida. He's been taking some fabulous images and doing some work on trying to get micrometer readings and seeing what they're doing. And it seems like some of these impacts, according to reports that I've gotten, are seeming to be shifting a bit from their original position of impact.
Now, is that just a standard home video camera you're using there, Steve?
No, it's not the standard one that you would normally take. This thing is probably the size of 2 packs of cigarettes, and it fits neatly onto the eyepiece. Then you use, or onto the eyepiece area. You then put an eyepiece in, and then you project the image, and it can get to almost probably 60% of the television screen or monitor.
That's really a nice image. I think I can even see the shadow of a moon going across the face.
You can see the moon, and with the seeing as it permits, you can get, when the atmosphere calms down a bit, you're able to see vivid detail, and that's primarily what we're going to be doing. We can see it in real time. That's what's great about the video. With the CCD imagery, you have a frozen picture. You can then make measurements, the size, knowing when you took the picture, calibrated in universal time. You can compare that to the predictions and so forth.
Okay, thank you very much, Steve. Those are great images.
Oh, great.
We do know that Steve is not the first person to look up at the night sky and wonder, though.
Hereditary prince and count, sole companion, wise in sacred writings, who observes everything in heaven and earth, clear-eyed in observing the stars, among which there is no erring, who announces rising and setting at their times, with the gods who foretell the future, for which he purifies himself.
Small comets measure several inches in length, but the larger ones may extend across the entire heavens. The appearance of a comet predicts military activities and great floods. Brooms govern the sweeping away of old things and the assimilation of the new.
Still lingered in the high constellation of the Bull.
As if driven by the storm,
countless leaping stars flashed through the upper atmosphere, and all around, lightning flashes cut the heavens. A comet spread its disheveled light.
Your vassals, the astrologers, soothsayers, and diviners, have been careless. That sign in the heavens has been there for some time, and yet you describe it to me as if it were a new thing. I thought you had already discovered it, and that your astrologers had explained it.
Rising every day, every hour, every moment, full of stench and horror, before the face of God, and becoming gradually so thick as to form a comet, with curled and plaited tresses, which at last is kindled by the hot and fiery anger of the supreme
On the other side, incensed with indignation, Satan stood unterrified, and like a comet burned.
While we're busy looking at the comet, my guest Anthony Avini is observing us. He's an archaeoastronomer, which means he studies how different cultures through history have studied the heavens. He's a professor at Colgate University and is the author of Conversing with the Planets. You know, our ancestors saw comets as omens. So what were some of the omens that they read into comets?
Well, Terry, you know, for thousands of years and across hosts of cultures, comets have been the irregular punctuation marks that dot human history. For example, in the year 684, violent storms ravaged Central Europe. They were linked to the appearance of a comet. In 1066, most of us have heard the story of why England fell to William the Conqueror, Halley's Comet. And the little clip you showed just before the start of our little discussion here of King Moctezuma standing on the terrace of his temple witnessing a comet. One of his courtly astrologers said to him, you know, this is going to be bad news for us, bad news for the empire. A few years later, in walks Cortez and the conquistadors. The history of this continent has never been the same.
We're approaching the end of the millennium now. I guess that would make it even more auspicious,
and I think
right?
we can expect that as we grind closer and closer to setting the hands of the clock to that cosmic midnight of the year 2000, we're going to hear more and more things about the significance of astral bodies and things that happen in the
So you think
sky.
people today are seeing the comet as an omen?
I think very much so, and this has been my observation as I've watched the developments here tonight. We heard the Shoemaker-Levy team and Derek also refer to the dinosaurs and the impact and what would happen if it happened on Earth. In effect, an omen is a kind of a reminder of something that might befall us or might happen to us. It doesn't have to be bad. Generally, it is bad with comets. So we are recognizing the fact that, well, something could happen in the future, and we need to think about it.
There's a wonderful quote in your book that I want to read and get you to comment on. It's from a cosmologist named Steven Weinberg, and he said, the more the universe seems comprehensible, the more it also seems pointless. There is no solace in the fruits of our research. Are you ever afraid that we risk losing some of the meaning of a comet crash of this magnitude by looking at science, technical stuff? Do you think about that?
Well, I think we do. It makes me wonder, hearing that quote, which of course is Weinberg's, is why should a Nobel laureate be so depressed about what he's doing? But I think the problem is that we tend to stick to the technical, mathematical explanations. We willfully made the choice to separate spirit from matter 500 years ago.
Our ancestors didn't do that, right?
No, they didn't.
Back in the old days,
comets
science and
were
religion
part of the religious panoply. They were objects to be watched because they represented the gods, and people had something to pray to, something to pay homage and offer something to. We, in a measure, in a way, don't have that. Although watching the event here tonight, which is one of the great spectacles of all times, does maybe make all of us wonder, and I can see the glow in Heidi's eyes as she explains this, you know, maybe there's some meaning to it that's missing, and we have to wait for it later, don't we, to find out what it's about.
So very briefly, what did Jupiter mean in the past? People used to think that the planets told them things about their own lives. What did Jupiter have to say?
Of course, Arthur referred to Thor's hammer. He's the king of the gods.
Yeah.
There's a good reason why he should be the king of the gods, because Jupiter is not the biggest planet or the smallest planet in the sky as far as the ancients are concerned, because they watch things without a telescope. It's not the brightest or the faintest. It's kind of in the middle. It's not the fastest or the slowest. What better god to have as your king and the ruler of the gods, but the one who is fair and just, the one who mediates, the one who falls in the middle. And I think that's why Jupiter, I think it's pretty well acknowledged among the mythologists that that's why Jupiter holds that position, that high office.
What excites you most about this comet crash?
Seeing it. I mean, it's a once in dozens of lifetime possibility, but I think it's the way people have reacted to it. I think it's up for astronomy night. There's no question about it. And as an astronomer of old, I guess I'm so glad to see people go to their telescopes instead of just being glued to the tube all the time.
Well, thanks for sharing some of the excitement with us. You know, speaking of comets and omens, the tabloids have some gloomy predictions.
A 100 million megaton explosion in space will devastate Earth. Oh no, and I'm on tour. Hi everybody, this is your scientific expert reader, Fred Schneider of the B-52s. 20 comet fragments are speeding toward the planet Jupiter, and experts say that when they hit, the impact will cause an upheaval on Earth that will be far worse than Hurricane Andrew and the recent Los Angeles earthquake combined. Now that's bad. Yes, there will definitely be tidal waves and earthquakes, but if people will take precautions, like hide under a table when the fragments start coming, the loss of human life may be well under 100,000. So when you see those fragments coming, put up an umbrella, get under a table, or just roll up your windows in your car. Chances are they won't hit you. There will be tidal waves, earthquakes, and weather calamities, the likes of which will dwarf anything seen on our planet so far, says noted Japanese physicist and space expert Hiro Yukazumi. As you may know, we've always been interested in science, truth, and science fiction. And we've sort of blended the two in our music. We love outer space. So forget about life on Mars. There's life on Jupiter. But with a comet coming, there might not be after this, who knows? You have to form your own opinions on things. Even though it's from the experts, there's always hope. So don't worry, don't go into that bomb shelter, and don't start fighting with your neighbors over petty things, because it could all end tomorrow. So, with that in mind, I think I'm gonna go read a book.
Believe it or not, someone has already thought out the scenario of what would happen if a cosmic interloper was on a collision course with Earth. David, I'd like to ask you, what do you think, who do you think this comet is for? Is this comet for astronomers? Is it for the general public audience? Who do you think it's for?
This Shoemaker-Levy 9 is not just the professional scientist comet. Shoemaker-Levy 9 is everybody's comet. This is the comet that in its death is visible by anyone with a small telescope. And not just because people can see it, people can see the results on Jupiter, but because people can stop for 1 week and people can think about what all this means. We have had impacts on the Earth before, long before we were here. We've had impacts on the moon. You can see those with a pair of binoculars any night that the moon is out. What hasn't been added to this equation, what we haven't seen yet, is an actual, real, live, bona fide impact. Up until July 16th, we weren't really sure, with all of our best calculations and predictions and Ouija boards and everything we could find, just how good this impact was going to be. And on July 16th, when the first puny little comet landed into Jupiter's atmosphere, and we saw this enormous plume leap up 1,000 miles above Jupiter's cloud tops, the thrill that everybody got was just fabulous. And I think in the cheering astronomers at the Hubble Space Telescope, the world was cheering also, because finally nature has thrown us a home run, and I think this is something we can all enjoy. It's a major event in the solar system, but not only that, it's an event that we're watching with everything we've got, from the Hubble Space Telescope and the Galileo spacecraft to little amateur telescopes, 4-inch diameter telescopes that amateur astronomers have bought, and the public going to star parties at observatories and planetaria are able to enjoy this as well. Isn't it great that on the 25th anniversary of Apollo 11, we can watch something like this?
Well, that's really wonderful. It does give us an opportunity, it gives everybody an opportunity to take a look at it, and hopefully we'll get a chance to look at those Hubble Space Telescope images. If we could look at image number 17 really quickly, we might get a chance to see that plume that you've been describing, David, and have a chance to sort of describe that plume. And here we can see, Heidi, what that plume looks like. Tell us just briefly what it's about.
This is one of the very first images we saw. We saw the plume. This is a view of the impact site itself. And it looks like the comet was coming in from the bottom and smacking into the atmosphere and then blowing out back. And that sort of, that bright area to the side there is just an ejecta blanket from this gigantic explosion. That's sort of that arc-like shape.
This little piece right down around here.
Well, yes, that's it. That's right. That's just like an ejecta blanket blown out of the atmosphere. This was the very first one, and this is a small one. When we saw this, we were jumping up and down.
Now, are we seeing more of these around some of the other images from
All
Hubble?
of them are looking very similar to this. All of the impact sites that are significant fragments. One of them was too small. Little B and little D, they're just little circles. They don't have those beautiful streaks and plumes. But the large fragment, G, I hope we get to see a picture of it later on in the show. That has amazing structure, absolutely incredible. We're going to be thinking for years and trying to figure out what that particular one's all about.
Okay, great, thanks. Well, now let's think a little bit about what would happen if this were to happen to us here on Earth. Let's hear a little bit from Hammer of God.
Kali 2 entered the atmosphere just before sunrise, 100 kilometers above Hawaii. Instantly, the gigantic fireball brought a false dawn to the Pacific, awakening the wildlife on its myriad islands, but few humans. Not many were asleep this night of nights, except those who had sought the oblivion of drugs. Over New Zealand, the heat of the orbiting furnace ignited forests and melted the snow on mountaintops, triggering avalanches into the valleys beneath. By great good fortune, the main thermal impact was on the Antarctic, the one continent that could best absorb it. Even Kali could not strip away all the kilometers of polar ice, but the great thaw would change coastlines all around the world. No one who survived hearing it could ever describe the sound of Kali's passage. None of the recordings were more than feeble echoes. The video coverage, of course, was superb and would be watched in awe for generations to come. But nothing could ever compare with the fearsome reality. 2 minutes after it had sliced into the atmosphere, Kali re-entered space. Its closest approach to the Earth had been 60 kilometers. In that 2 minutes, it took 100,000 lives and did $1 trillion worth of damage. The human race had been very, very lucky. Next time, it would be much better prepared. Though the encounter had altered Kali's orbit so drastically that it would never again be a danger to Earth, there were a billion other flying mountains orbiting the sun, and Comet's swift tuttle was already accelerating toward perihelion. There was still plenty of time for it to change its mind again. Arthur C. Clarke is back with us by video phone from his home in Sri Lanka. That's a pretty scary ending you gave your novel, Hammer of God. What's the probability of a comet like that actually causing such destruction on Earth?
Well, it's not a probability, it's a certainty, but we don't know when it will happen. And of course, you now have the technology to prevent it happening, because one of the things the Shoemakers and Levy are doing is trying to make a census of what dangerous objects there are in space. They've been doing it on a shoestring budget. I now hope that they're going to get some real money to do their work. And then when we know what dangers there are, we can prepare to meet them. There are numbers of ways that it could deflect comets or asteroids with the technology which we can foresee today.
Like sending up nuclear missiles or something to destroy them. But let me ask you, how did you create the after effects of the comet crash in your novel? How did you decide to have the comet change the shorelines and destroy some of the polar caps and kill, was it 100,000 people?
Well, I mean, that's my science fiction writer's imagination. I could have constructed a much worse scenario. But when you start to think of what these things could do, it's obvious what some of the impacts would be. I must apologize to my friends in New Zealand for burning them up.
Oh, yeah. Was there a comet that inspired your comet, Kali?
Kali, no. But I've been interested in this for many years, and of course, it's a curious coincidence that I was a great friend of Louis Alvarez. I worked on his GCA radar during the war, and of course he was a man, and he and his son Walter, who put forward the theory, which in his last letter to me he said was no longer a theory but a fact, that a comet or an asteroid wiped out the dinosaurs.
You know what I really want to ask you? Do you ever wish that you had traveled to another planet? Or someplace else outside of Earth?
Well, I would, of course, like to have gone to the moon. I'm a little too old for that sort of thing now. I'm afraid there aren't going to be any tourist flights to the moon in this century. But I've seen so much happen in my lifetime that I never dreamed would occur, including this event, of course, that I am quite satisfied.
Well, speaking of this event, how does this event compare to what you imagined? Your job is to imagine things like this happening. Now, a comet has actually crashed into a planet. We've been able to watch it. Is it anything like you imagined it would be?
Well, I haven't actually seen anything myself directly. I'm hoping tonight, if the sky is clear, that I may see some of the after effects. But really what we've seen now is what we hoped to see, but what we're afraid we wouldn't see, because a lot of people thought that these impacts would be a fizzle, particularly as it was on the other side of Jupiter. So that we're all delighted that, the results are so visually spectacular.
Arthur C. Clarke, a pleasure to have you here. It was very good to see you, or to sort of see you on your video phone. Thank you so much. David Levy, we've saved the last word for you. You know, I guess we shouldn't take for granted that the solar system as we know it will always stay exactly the same.
No, it won't. The solar system is an evolving place. If you were, you know, in grade 4 textbooks, we learned, in grade 4 textbooks, we learned about that the solar system was completed 4 billion years ago. Well, now we know that's not true. Now we know that if you were to go around Jupiter right now, that there would be a little yellow construction fence there, and it would say, danger, keep out, solar system under construction. What we're seeing this week is the solar system grow up a little more. We on Earth and the other planets are sort of pausing this week to take a look at this planet in distress, Jupiter, and we have a chance to participate in that too. And that's what's really so much fun about this.
When the solar system is changed, is it usually by something this violent, or is it often through something more slow and evolutionary?
Well, it can be. These violent events are the primary way of change, but you know, there's a little particle, little tiny microscopic particle called a Brownlee particle. These particles land about 1 every square meter of Earth's surface every day, some number like that. Very, very gently. And the Earth actually increases its weight by a little bit from all of these small particles of cometary dust. You can actually, on high-flying airplanes, you can actually collect these things. So there's a gradual change as well. We also see that every night near the sun is something called the zodiacal light. It's up in the evening sky and then in the morning sky.
You know, we've been talking about the impact of the comet on Jupiter. I'm curious about the impact of the comet on your 3 lives. I mean, what it's been like for you to just observe the awesome power of the comet.
I think the most fun thing that the 3 of us have as a team when we're observing is that when the sky is beautifully clear, and we have worked really, really hard with Gene and I taking photographs, and Carolyn scanning these photographs and sometimes changing those roles. And we've taken maybe 65 or 70 films, 8-minute exposures during that night. When it's all over, and I press one button and the big shutters of the dome start to close, shutting out the sky at the end of a beautifully successful night, it gives me such a feeling of satisfaction that I'm working with Gene and Carolyn. It's just so much fun to work with them.
David, thank you so much. We're going to let you all get back to your shindig. Congratulations again. This week we're getting glimpses of a kind of comet crash that has never been seen before. And as scientists continue to interpret the data, we will still be left with many mysteries about the cosmos and our place within it. In the meantime, there's still 2 more days left of this comet crash. Derek, what do you expect will happen?
Well, Terry, as you mentioned, there's still 2 more days to go.